Friends, today we will see another method, subset construction method, which will be solving a conversion of regular expression to a finite automata. Consider the example 1 0 plus 0 plus 1 1 0 star 1. So this is the given regular expression. With the subset construction method means it is nothing but a process for converting any non-deterministic finite automata into a deterministic finite automata. So simply we are converting a NFA to a DFA. So it is a regular expression given over here. So initially we have to convert this NFA regular expression into NFA, then we have to convert it into a DFA, right? So next we will see what we have to do. So again, simply step by step for your simple understanding, I am splitting this. It is a union part, right? So from a starting state to the ending state with a 1 0 it is moving, and again union means where we have started the other part, the same place, same node itself we have to start the second part also. This is the next part, right? So the whole thing we are moving with the another way, from the starting state to the ending state we are moving, right? So how we can split these part? Next what we have to do, this is 1 0, so you have to split it, right? So with 1 it is moving to a state, and with 0 it is moving to the final state. Similarly here also we are making a split 0 plus 1 1. So with 0 plus 1 1 it is moving to another intermediate node, and from here 0 star 1 it is moving to the end state. Again we are splitting these two parts here. See, the above part it is same, no changes I have made. Here also 0 plus 1 1 simply I am keeping for the while 0 star 1. How I am changing? 0 star. I am making a change here, and with 1 it is moving from this intermediate node to the final state. Next I want to split this 0 plus 1 1. See how I am making that 0 plus 1 1 into a different picture. See, 0, with 0 it is coming to this intermediate node, and with 1 it is going to another intermediate node. From there it is again coming to this intermediate node. 0 plus 1 1. So I made again the remaining as the previous stage. So this is the expected DFA for the regular expression. Now simply I am making a transition table of it. How we can make a transition table? See how many states we are having here? 1 2 3 4 5. So all the 5 states have mentioned here, right? And again how the CE came here I will explain to you. See, remaining 1 2 3 4 5, the whole 5 states I have mentioned here. In this diagram the starting node is A, so I am making this as starting node, and the ending node here it is B. So I am making this is the ending node. Either you can represent it with the asterisk symbol, or even you can round it, right? So this is how you will be representing the ending state. Remaining all the states I have mentioned, right? Now how it is drawing? See, only 0 and 1, two inputs we are having. So from A on 1 it is moving to C, and on 1 it is moving to E also. So we are making a new combined state CE, and on input 0 it is moving to D. So we have mentioned here. Next is C. From C on input 0 it is moving to B, and on input 1 there is no transition. So we are making a null 5 value here. Okay. From E on input 1 you are moving to D. On input 0, see it is again doesn't have any transition, so we are making a null value. Okay. From D on input 0 it is D itself. On input 1 it is moving to B, right? Now next is we had a combined state, right? CE. So CE, what we are writing? From CE, obviously on input 0 and on input 1 it has to reach the final state. So we are mentioning the final state for the combined state. And finally our final state doesn't have any incoming flow, only outgoing flow it is there. So on input 0 it doesn't have any transition, on input 1 it doesn't have any transition, so simply we are making null value. So this is the expected transition table. Now we'll see a example 2, 0 star 1 plus 1 0. How we are drawing this particular regular expression into a DFA, that we will see now. So here with the help of epsilon moves we are performing this. So what are the steps means, regular expression to NFA with epsilon moves initially we will be doing. Then the NFA with epsilon moves, from that to without epsilon moves we are making. Then finally the NFA to DFA we are making. Okay. Now we will see how we are solving the particular problem. Step by step we will see how we are doing it, right? So initially this is a starting state, and 0 star 1 we are moving to another state, and it is a union. So again from the same state Q0 to the next state we are having the 1 0. So this is the first step. Now we have to split all these two. The next other steps, if we want we can add the intermediate nodes also, right? Now we will see how we are drawing this. So from Q0 to see from Q0 to nothing. With epsilon we are moving to the next state Q1, and what is that, we are having 0 star. So here we are making a 0 star, we are giving a self loop, and from Q1 without any input with epsilon we are moving to the next state, and what we are having next, with 1 we are moving to the end state, right? Now this part is over. Now we have to do this next part. So again 1 0. So with 1 we are coming to next state Q4, and from 0 we are coming from Q4 to the next state Q5. So we are making these two states as the final state. So this is the expected NFA with epsilon moves. Now we have to remove the epsilon so that we can get a perfect DFA for it, right? So simply what we are doing, we are removing this epsilon. So simply Q0 as the self loop, and 0 star we made. Then again from the starting state to 1, with 1 we have to move. So with 1 we are going to next state. Again it is a union. So this part as it is we are drawing. Actually what we have did, this epsilon transition, everything we have removed. So this is the expected DFA for it. I expect today's class is clear to you. If you are having any queries, kindly put it on the chat box. Thank you for watching the video. Kindly do like the video and put few comments also. Thank you.